Hello everyone, a very good evening to all of you. Very good evening. So in the last class yesterday, we have done the revision of shear force diagram and the bending moment diagram chapter. Okay, so and today we are going to do the revision of stresses in beam. In that we will discuss about the bending stresses and the shear stresses. If you remember, when I started the simple stress and strain, then I told you we have two types of stresses. One is a normal stress, one is a shear stress. In the normal stress also we have two stress, one is axial stress, other one is the bending stress. In shear stress we have two stress, one is direct stress, direct shear stress, other one is the indirect shear stress. So direct shear stress will come due to the direct shear force, indirect shear force will come due to the torsion, and in axial force which we have Hello everyone, now am I audible? Now am I audible? Anyone confirm? Chetan, Rahman, please confirm. Am I audible? Alright, thank you Chetan. Alright. So in the yesterday session, if you remember, we have done the concept of shear force diagram and the bending moment diagram. We have only 3 to 4 concepts. If we know those 4 to 5 concepts, we can draw any shear force diagram and bending moment diagram. Only we need hardly 4 to 5 concepts for drawing the shear force diagram and the bending moment diagram. Right. Other than that, today agenda is we are going to discuss the stresses in beam. So mainly we will discuss about the bending stresses and the shear stresses which will come due to the direct shear force. Okay, if you remember, we have two types of stresses. One is normal stress, one is shear stress. In the normal we have two stress, one is axial stress, other one is bending stress. Similarly in a shear stress we have two types of shear stress. One is direct shear stress, other one is indirect shear stress. Okay, so indirect shear stress comes due to the torsion, direct shear stress comes due to the direct shear force. So our today agenda is we are going to discuss about the bending stresses and shear stress which is coming due to the direct shear force. Okay, and other than that, GATE have added one more topic, that is the shear center. Yesterday someone have posted in a chat box, shear center is a quite difficult. So thing is this, we are not going to do the PhD of any topic, right? Our agenda is to understand the concept, solve the question, get the marks. Okay. Whatever the new topics are adding in a gate year by year, you will find the questions, those are coming from those topics are really very easy. Okay. They will just touch that either formula or just direct definition. They will not go in much detail of the topics which they have recently added, removed. Okay. CS Center is the topic which is added many times and also removed from the syllabus many times. Okay, so no need to worry about this much about the CS Center. We will discuss about 4 to 5 points. 99% the question is going to come from those 4 to 5 lines only from the CS Center. Okay, other than that you will not get the question from the CS Center. Okay, alright guys. So today I am going to start with the stresses in beam, right? Stresses in beams. So first I am going to discuss here about the bending stress. About bending stress. The beauty of this bending stress is all the numericals are based on only one single formula. Okay, all the numericals are based on one single formula in a bending stress. I hope all of you know that's known as bending equation. That's also known as Euler's formula. Okay, that's also known as flexure formula. So only one single equation is there. Based on that, all the questions will be solved from the bending stress chapter. Okay, what is that equation? I hope so all of you know. The equation is m upon I is equals to sigma upon y is equals to E upon R. This is the equation. M upon I is equals to sigma upon y is equals to E upon R. What is m here? M is bending moment at section. M is bending moment at the section. M is bending moment at the section. What is I? I is moment of inertia about neutral axis. I is moment of inertia about neutral axis. What is sigma here? Sigma is our bending stress. Sigma is our bending stress. Y is very much important. Y is very much important. Why it's important? Y is the distance of the fiber where you want to calculate the bending stress, but the y will be always calculated from the neutral axis. Okay, y will always calculated from the neutral axis. So I am writing y is distance of fiber from neutral axis. Okay, you have to always take the distance from the neutral axis at which fiber you want to calculate bending stress. That's it. Okay, because sometimes they will ask you about the maximum bending stress. So maximum bending stress, everyone clear ki we will take the maximum distance whatever possible. But sometimes what happened, many times they will ask in between some fibers. So we got confused, we have to take the distance from the top or the bottom. Be clear, this y is always distance of the fiber from the neutral axis. Okay, now don't forget this. E is our Young's modulus or modulus of elasticity, and R is our, anyone know what is R here? Anyone know what is R here? What is R here? Anyone? What is R here? Anyone can tell? What is R here? R is our, anyone? R is our radius of curvature. R is our radius of curvature. You will ask me, sir, why, how the radius is coming into a picture? The chapter is bending stress and the radius is coming. Radius we generally study in a geometry, right? Circle is there, then only you will study about the radius. But here we are saying R is the radius of curvature. But the thing is this, while we derive this equation, we assume so many assumptions, right? We assume so many assumptions. So we assume that when the beam will bend, let us say this is my beam, This is my beam. So we assume that this beam, when this beam will bend, this beam will form a circle, and the radius of this circle is called as radius of curvature. Okay, we assume that when the beam will bend, it will form a arc of circle, and radius of that arc is known as radius of curvature. One more thing, anyone can tell me what is 1 by r? R is radius of curvature. What is 1 by r? R is curvature. Sorry, R is radius of curvature. What is 1 by r? Anyone? What is 1 by r? Anyone? Chetan, Jaswant, Mayank? Anyone? Bhagyasiri? 1 by r is very good, Mayank. 1 by r is known as only curvature. Okay, in the mechanical, these terms are not touched up to now, but it can be touched in the upcoming exam. In the civil, these terms have been touched already. Curvature and radius of curvature. Okay, so 1 by r is known as curvature, beta. In the whole strength of material, whenever the questions will come related to the curvature, means this formula have to be used in the question. Okay, this formula only have to be used if question is talking about the curvature to you, or because we have not studied any other formula in the whole civil engineering about the curvature. This is the only formula which is related to the curvature. Okay, so any question is coming to the curvature, means you have to apply this equation. How to apply it depends upon the question demand. How the question want you to apply this equation is the question demand, right? But definitely this formula is going to work. You can try the problem whichever have come in the exam, but meaning must be clear to you. R is radius of curvature, 1 by r is curvature here. Okay, so this is the bending equation. All the problems related to bending will be clear from here. Okay, let's write some note now. Note 1. You know m upon I is equals to sigma upon y is equals to E upon r. I am taking first two terms. So m upon I is equals to sigma upon y. Can I say here sigma is equals to m upon I into y? Yes or no? Sigma is equals to m upon I into y. Can I also say here sigma is directly proportional to y? Yes or no? Sigma is directly proportional to y? Yes or no? Can I say sigma is directly proportional to y? Sigma is directly proportional to y means bending stress varies linearly. You know, if two quantities are proportional to each other, it means those quantity relationship is linear. So you can see bending stress is proportional to y. What is y? Y is the distance of fiber along the depth. So definitely bending stress is varying linearly here. I hope so anyone have no doubt about this, right? Bending stress always varies linearly, beta. Okay, and at the neutral axis, what is the bending stress? At neutral axis, what will be the bending stress? What will the bending stress at neutral axis? What will the bending stress at neutral axis? If any beam is here, okay, it is subjected to any loading, right? If you draw the bending stress distribution along the depth, how it will come? It will come like that. Okay, top portion will go under compression, bottom will go under tension, and here it will be 0, and here it will be 0. So bending stress at neutral axis is always 0. Why? By the common sense also you can say, because y is the distance from neutral axis. So distance of neutral axis from the neutral axis, it will be 0. So definitely bending stress will be 0 at a neutral axis, beta. Okay, anyone doubt in this one? I hope so, no doubt. So this is the one concept, bending stress always varies linearly. Second concept, note 2. We know m upon I is equals to sigma upon y. Again I am writing sigma is equals to m upon I into y. So can I say here m upon I upon y? Can I say? Can I say m upon I upon y, yes or no? Can I say this? So what is I upon y here? What is I upon y? What is I upon y? I upon y is called as, I upon y is called as what? I upon y is called as, I upon y is called as our z. I upon y is called as z. What is z here? Z is section modulus. Also we can say this is our flexure. Very good, Mayank. This is our flexure strength parameter. Okay. If two sections are given to you, two cross sections are given to you, and they are asking to you which cross section is good for the bending. So what will you do, beta? You always calculate z value for which section z is maximum. Then you will say that section is more stronger in bending. Simple concept. Okay. Like this is the favorite question. If I take one square, if I take one square of side A, and this square if I put like that, okay, again this is a square, this is called a diamond section actually. This is a square, I rotated this square and I am putting this square on the diagonal. This diagonal is horizontal. Okay, so which section will be strong? Which section will be strong? What you will do? You will calculate z for this. Let us say this is z1, this will be z2. You will calculate z1 and z2. Then you will notice which is more. If you do the calculation, you will get here z1 upon z2 is equals to under root 2. Okay, you will get here z1 upon z2 is equals to root 2 here, beta. Okay, so you can see here square section is more stronger. This question may come in the exam. What is the ratio of their section modulus? z1 upon z2 is equals to root 2. This question is very good question, but have not come in the exam. IAS exam have been asked this question many times. Okay, ES exam have been asked this question already, but in the gate also this question can come. The ratio of section modulus of square section and same square, if you rotate it, you put the side side inclined and the diagonal horizontal, you will get z1 by z2 is equals to root 2 here. Okay, so you can see square section is more stronger here, right? Square section is more stronger here. Rahman, I think your internet is lagging. If you will rejoin, it will be good for you. Okay, your internet is lagging, Rahman. Okay, so this is other point. So this is our flexure strength parameter, beta. Note 3. Note 3. What is note 3? Again, you know m upon I is equals to sigma upon y is equals to E upon R. Now I am taking these two terms. So sigma upon y is equals to E upon R. So can I say here what? Can I say here sigma upon E is equals to y upon R? Yes or no? Sigma upon E is equals to y upon R. What is sigma upon E? What is sigma upon E? This is our strain. Epsilon is equals to y upon R. Very important relationship for the exam. Actually, in the college times, when we solve the question, maximum time we don't use this term E upon R. Frankly, we solve this much questions and maximum question will be solved with the help of m upon I is equal to sigma upon y. Okay, maximum question will solve in the help of m upon I is equal to sigma upon y, and many times we forget this term E upon R, beta. So no need to forget the term E upon R, because in GATE 2019 the first time the question have come by using this E upon R, beta. Okay, this question have been come in GATE 2019 first time they have used the formula epsilon is equals to y upon R. Okay, what they have given? They have given the strain value and they have asked there the curvature. Okay, they have asked the curvature there. So that's why don't forget strain is equals to y upon R. This can be, if strain is given to you and some radius of curvature is talking. So I already told you, if radius of curvature is there, you have only one equation that is going to help you. Now you have to play with that equation. How you are playing, it's up to you. This is the maximum way you can play with the equation, beta. These are the quantity you will get from the equation. So question may come in the exam. One is directly from the bending stress. They will ask you to find the bending stress. Second, they can ask you the question on section modulus. Okay, Third, they can ask you the question on strain and this radius of curvature beta. Okay, so these are the things possible. These are the things possible which the question have come from the previous year. Okay, one more topic now. Force shared by hedged area. Force shared by hedged area. The force shared by hedged area. What is the force shared by hedged area? Let us suppose we have one section here. Okay, we have one section here and this is the neutral axis. This is the neutral axis of this section, right? And the question is asking to you, and this, let us suppose this section is subjected to bending moment M and I is the moment of inertia. Okay, I is the moment of inertia. So question is asking to you here, let us suppose some area is hedged from here. This area have been cut. The particular area is there, small area, and question is asking to you how much force is shared by this section. How much force is shared by this hedged area. Okay, so how you will do beta? How you will do? Let us suppose area of this one is A. Area of this one is A. So how you will do? F is equals to M upon I is equals to A into Y bar. Okay, M upon I also can be written as sigma upon Y. Sigma max upon Y is equals to, into A into Y bar. If the question comes force shared by the hedged area, you have to apply this formula. Now thing is, M is bending moment, M is bending moment, I is moment of inertia about neutral axis. Always moment of inertia is about the neutral axis. Okay, all the times moment of inertia is about the neutral axis only. And here A into Y bar. What is A here? A is the hedged area. Whatever area they have been hedged, area of that section is A. What is Y bar? What is Y bar here? Y bar is distance of centroid, of hedged area from neutral axis. Okay, the distance of centroid of hedged area. सर ये y max है ना? डेफिनेटली सिग्मा मैक्स कब होगा बेटा? अगर सिग्मा मैक्स मैं बोल रहा हूं तो यहाँ डेफिनेटली y विल बी ऑल्सो मैक्सिमम, राइट? सिग्मा मैक्स जब तभी होगा जब y भी मैक्सिमम होगा, राइट? तो y बार क्या है यहाँ पे? y बार इज द डिस्टेंस ऑफ सेंट्रॉइड ऑफ hedged area from neutral axis. So this is our neutral axis. So some centroid will be there here. Centroid will be exist of that area. So y bar is the distance of centroid of that area from the neutral axis beta. Okay, the distance of the centroid from the neutral axis. This is very important beta. Okay, this is very important. This is very important. So you have to remember. Okay, this will be y bar. This will be y bar, right? Y bar is the distance of centroid of the hedged area from the neutral axis. The question have come already one time in GATE 2006 in a civil engineering. Okay, only the one time the question have come in a 2006, but 2006 is important for us because IIT Kharagpur. Okay, so that's why this concept is more important beta. This concept is very much important, right? Next is, anyone doubt in this concept? 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 All right. Next is moment shared by, first we have written force shared by the area. Now we are saying moment shared by the hedged area. Okay, anyone can guess the formula now? Anyone can guess? Here we have written sigma max upon y max is equals to a into y bar. Okay, a into y bar, sigma max upon y max, right? So anyone can tell me now what is the moment shared by hedged area? One time the question have come in ES already from this moment shared by the hedged area. Okay, so let us suppose again we have one body. Okay, this is the neutral axis. This is the neutral axis. This is the neutral axis, and here we hedged some area. Here we hedged some area, and the moment applied on this complete section is m. On this complete section, moment applied is m. Okay, so what is the, how you will calculate the moment shared by this hedged area? I am saying moment shared by this hedged area is m dash. Moment shared by this hedged area is m dash. Okay, can you tell me how you will calculate moment shared by the hedged area? How will you calculate? If total moment applies m, how much moment will be shared by this hedged area? So thing is, I am writing here m dash upon m is equals to I dash upon I. What does it mean? M dash upon m is equals to I dash upon I. What is m dash? Which we have to find. M is what? M is the moment applied. M is the total moment applied. M is the total moment applied on the section. Total moment means bending moment. Okay. M means bending moment applied on the section. I dash is what? I dash is moment of inertia or moment of area of hedged section about the neutral axis of complete or full section. Okay, about neutral axis of full section. Full section means the complete section, means you will calculate the moment of inertia of this hedged area. Okay, moment of inertia of this area about this which axis? This axis, which is original neutral axis we have of the whole section. Okay, so m dash upon m is equals to I dash upon I here beta. M dash upon m is equals to I dash upon I. I am predicting these questions can come. This topic or this topic can come in the exam. Okay, force shared by hedged area and the moment shared by hedged area, both are very moment shared I am saying because the gate have been not asked the question from this up to now. Okay, the gate have been not asked the question up to now, right? So that's why I am saying this topic is important. M dash, just you have to remember moment of inertia. Okay, the ratio of moment of inertia we have to take, that will be fine, because sigma max upon y max will be same for m also and m dash also, that will be cancelled. The ratio will be m dash upon m is equals to I dash upon I. The formula is not the rocket science. Okay, you know m is equals to sigma max upon y max upon I. So I am writing this formula from here only. Okay, I am writing this formula from here only. M dash upon m is equals to I dash upon I. Okay, anyone doubt? Anyone doubt? Anyone doubt in a bending stress? So this is the complete bending stress. Okay, one equation is there and these are the some concept of bending stresses. All the questions can be solved help of this. All the questions can be solved with the help of this. Okay, one more concept. Combined axial and bending. Combined axial and bending. Combined axial and bending. What is this concept? Let us suppose, open the eyes very carefully. Okay, open the eyes very carefully. Let us suppose we have one cantilever beam and this is the neutral axis. This is the neutral axis and this is the cross section. Let us say I am saying rectangular cross section is there beta. I am saying cross section is rectangular, B is width, D is depth and here it's a neutral axis. Up to now, what we have seen, the force is applied on the neutral axis, and then you say the stress is directly P upon A, right? The force will be applied on neutral axis, then you say it's a P upon A, right? But I am saying, let us suppose the P is not applied at the neutral axis, the P is applied somewhere here. The P is applied somewhere here. Now somebody is asking to you, the questionnaire is asking to you, calculate the stress at section XX. The calculate the stress at section XX. Now if the load will be at the neutral axis, then you will say, sir, it will be P upon A. Area is B into D, so it will be P upon BD. But here if you see, the load is not applied at the neutral axis, the load is applied somewhere else on some eccentricity, okay. This distance, you can say this distance will be D by 2 here. It can be at any distance. It can be at any distance, but we know one thing, how to transfer the force at the neutral axis, right? Yesterday also we have seen the question in a bending moment. Here also we have to apply the same concept. What will we do here? We will transfer the force at the neutral axis. So can I make this diagram like that? Can I make this diagram like that? Just see all of you. This is my original beam. This is our neutral axis. This is our neutral axis. Now again apply the same concept. I want to transfer this force at the neutral axis. How will we transfer? We will apply the P at the neutral axis, 1P like that, 1P like that. So you can see this P and this P will form a couple. This P and this P will form a couple, and this P will be, it will be P is the force which it will come, and second it will be P into D by 2. You can see how the couple will come here, clockwise, anti-clockwise. These two forces are equal opposite parallel forces. So two equal opposite parallel forces form a couple. So it here the couple will be P into D by 2. The couple will be P into D by 2. So now you can see this is my section XX. This is my section XX. So if somebody asks you to calculate the stress at section XX, it means you have to consider the effect of P also, and you have to consider the effect of bending moment also. It means at section XX the stress will come due to axial force as well as bending moment. Okay, so sigma at XX will be sigma due to axial plus sigma due to bending. Okay, and you know axial force. What is axial stress? Axial stress will be P upon A. So P upon A will be how much? B into D. Axial stress will be P upon A, it will be B upon D. Bending stress is how much? I am saying plus, it can be plus or minus. Why I am saying plus or minus? Because I am not mentioning exactly where. Either a question will say to you, find the maximum stress or the minimum stress. If maximum they are saying, you have to add both. Minimum they are saying, you have to subtract. Okay, maximum you have to add, minimum you have to subtract. I am just saying stress at section XX, it can be maximum or minimum, and here you will write M upon I into Y. M value PD by 2, I BDQ by 12, Y will be D by 2, right? So you can calculate like that. The concept here is, the load is not applied at the neutral axis, then definitely bending moment effect will also come while calculating the stress beta. That's the concept of combined axial and bending. Okay, it's a combined axial plus bending. The question is, कौन सा न्यूट्रल एक्सिस बेटा? न्यूट्रल एक्सिस यहीं पे है, न्यूट्रल एक्सिस यहीं पे है, न्यूट्रल एक्सिस कहीं नहीं जा रहा, ठीक है, न्यूट्रल एक्सिस कहीं नहीं जाएगा. जो न्यूट्रल एक्सिस जहां पे तुम ले रहे हो उस सेक्शन का न्यूट्रल एक्सिस से मतलब है. I have to take care about the neutral axis of moment of inertia, where my section is. My section is here, so I will take about this section where the neutral axis is of this section. Okay, from the question it will be more clear to you. GATE 2008 asked the very good question from this concept. Means if I am saying it's section XX, so you have to see the section XX neutral axis, where the cross section XX neutral axis is. Okay, that accordingly you have to take here I also and Y also. Okay, Mayank? Okay, Let's solve some question on the concept which we have covered. Then we will discuss about the shear stress. Okay, shear stress is very small topic. All of you know, right? The questions are also very rare on the shear stress, but bending stress questions are frequently in the exam. So take care about the. It's the free marks. Okay, these chapters are really free marks. One formula is there, and you can get the marks. Okay, you have to remember only one formula, and you will get the marks. Right? सर पर बीच में तो फोर्स है ना बेटा फोर्स क्या है क्या मैं यहाँ पे मेथड ऑफ सुपरपोजिशन लगा सकता हूं क्या मैं यहाँ पे मेथड ऑफ सुपरपोजिशन लगा सकता हूं ये यस और नो कैन आई से दिस बीम कैन बी ड्रॉन लाइक दैट वन इज पी एंड हियर इट विल बी पी डी बाई 2 अब बताओ ड्यू टू दिस इट विल बी पी अपॉन ए इसका न्यूट्रल एक्सिस कहां पे होगा सेक्शन एक्स एक्स है यहां भी सेक्शन एक्स एक्स होगा तो यहां पे क्या होगा पी अपॉन ए यहां पे क्या होगा पी डी बाई 2 इसका तो न्यूट्रल एक्सिस कहां जाएगा यार फोर्स लगाने से न्यूट्रल एक्सिस चेंज थोड़ी हो जाएगा यहां पे कोई हम इलोंगेशन और इलास्टिसिटी की बात थोड़ी कर रहे हैं जो न्यूट्रल एक्सिस चेंज हो जाएगा यहां पे ठीक है तो यहां से you can apply the method of superposition it will come in the this way only in the last okay all right let's solve some question now okay let's solve some question on this concept then we'll go ahead to the shear stress chapter the first question do it very fast okay do it very fast all of you do it fast all of you do it fast what question is saying beta consider an elastic straight beam of length 10 pi meter length is equals to 10 pi with square cross section of side 5 mm a is equals to 5 mm and that is square cross section it's a square and Young's modulus 200 GPa E is equals to 200 GPa E is equals to 200 GPa okay and this straight beam was bent in such a way that the two ends meet the straight beam was there the beam was straight okay after applying the bending moment the beam have been bent in such a way the two ends have been meet means it have become completely circular it have become completely circular right and to form a circle of mean radius r and radius of this circle is r right assuming the Euler-Bernoulli beam theory जो थ्योरी जो पढ़ाई है उसका नाम यूलर्स बीम यूलर्स थ्योरी है ओके जो थ्योरी अभी पढ़ाई है यूलर्स बर्नौली थ्योरी इसलिए बोल दिया जाता है क्योंकि जो एक अजम्पशन है उसमें प्लेन सेक्शंस रिमेन प्लेन बिफोर बेंडिंग एंड आफ्टर बेंडिंग दैट अजम्पशन इज नोन एज बर्नौली अजम्पशंस ओके दैट्स व्हाई वी से इट्स अ यूलर्स बर्नौली थ्योरी ओके is applicable to the bending problem the maximum tensile bending stress in the bent beam is okay all of you try and tell the answer 100 GPa question is asking to you answer in megapascal my question is asking to you answer here in megapascal you are saying in a gigapascal all of you try fast Rahman Bhagyasiri all of you do it fast length how much is given to you length is given to you 10 pi okay now what we have to find sigma here bending stress we know one thing what equation of bending stress is m upon I is equals to sigma upon m upon I is equals to sigma upon y is equals to E upon R right? M is not given to me, right? M is not at all given to me. Okay, so M is not given to me means this term is not useful for me, yaar, right? It means we have only sigma upon y is equals to E upon R. We have sigma upon y is equals to E upon R. Y पता है मुझे, E पता है मुझे, R अगर पता चल जाए तो मेरा गेम खत्म हो जाएगा. If I got to know R from somewhere, my game will be over. I will get the answer in a seconds, right? How you will get R? भाई सब कुछ तो दिया हुआ है यार. Question is saying to you the straight beam is bent into a circle. The beam is straight, it bent into a circle. One thing is here length is 10 pi, so this length will be equal to the circumference of the circle, yes or no? अगर length यहाँ पे 10 pi है तो यहाँ भी तो 10 pi होगी ना भाई. So what can I say here? Can I say here 10 pi will be equals to 2 pi r, yes or no? Can I say here 10 pi is equals to 2 pi r, yes or no? So pi to pi will be cancelled. R will come here 5 meter. Why meter? Because length is given to you 10 pi meter. So it will be 5 meter. R पता है, E पता है, वेरी गुड भाग्यश्री. R पता है, E पता है, सब कुछ पता है भाई. तो बता दो सिग्मा क्या है फटाफट. और निकालना क्या है, मैक्सिमम निकालना है. तो मैक्सिमम के लिए E upon R, Y will be also maximum. Because we want sigma max, definitely Y must be maximum. Put all the value and tell me how much it's coming. Put all the values, tell me how much it's coming. Very good, Mayank. Now it's correct. All of you do it fast. How much it's coming? Everyone try fast. Sigma is equals to E upon R into Y. E is how much beta? E is 200 GPa. Convert into megapascal. 200 into 10 to the power 3 megapascal. R is 5 meter. Convert into 10 to the power 3. Because we have to find the answer in megapascal, so convert into the mm. 5 into 10 to the power 3. And Y will be how much beta? Y will be A by 2. It means 5 by 2. If you put all the value and solve here, answer will come here 100 megapascal. So answer is here 100 megapascal beta. Answer is here 100 megapascal. Anyone doubt? Anyone doubt? Anyone doubt? It's clear? It's clear. Anyone doubt? Very good Bhagyasri, very good Mayank. Let's move to the next question. Try this thing, this question fast. Try this question fast. रहमान बेटा, एक बीम दिया हुआ है यार मुझे, ठीक है, ये जैसे बीम है मेरा. क्वेश्चन ने बोला ये बीम था बेटा, आफ्टर अप्लाइंग द बेंडिंग ना, ये बीम जो है सर्कल बन गया. ये बीम जो है सर्कल बन गया. अगर बीम की लेंथ पहले जो थी, कुछ भी लेंथ होगी यार, मुझे नहीं पता, कुछ भी लेंथ होगी, अगर वो सर्कल बन गया तो बीम की लेंथ तो सेम ही रहेगी ना यार. जैसे कोई रबर बैंड होता है यार, रबर बैंड तुमने काट दिया, रबर बैंड तुम्हारे हाथ में है, अगर तुमने उसको घुमाया, उसकी लेंथ तो सेम रहेगी ना. तुम कुछ भी शेप दो यार उसे, तुम चाहे ट्राइंगल शेप दे लो, चाहे कुछ भी दे लो, जो लेंथ तुमने इनिशियल ली है वो लेंथ तो सेम रहेगी. तो पहले लेंथ क्या थी, 10 पाई थी. तो क्वेश्चन ने कहा वो सर्कल बन गया यार. तो तुम्हें पता है सर्कल की लेंथ क्या होती है, सर्कल की सर्कमफ्रेंस क्या होती है, 2 पाई आर. 2 पाई आर. तो मैंने क्या करा, 10 पाई को कंपेयर कर दिया 2 पाई आर से. मैं क्यों कर रहा हूं ऐसा, क्योंकि ये मुझे पता है कि मेरी इक्वेशन ये है और m के बारे में मुझे क्वेश्चन ने कुछ बोला नहीं है, तो डेफिनेटली m अपॉन i तो मैं यूज कर ही नहीं पाऊंगा यहाँ पे. I have to use only sigma upon y is equals to E upon R. So what will we do beta? What we have to do? We have to use the R only. How can I find R? R I can find in this way. Just put all the value in the formula. You will get the answer. Okay. That's it. Clear, Rahman? Clear? Next question. All of you try fast. Next question. All of you try fast. All of you try fast. देखते ही खत्म हो जाना चाहिए क्वेश्चन, देखते ही खत्म. आंसर क्वेश्चन क्या कह रहा है भाई, क्वेश्चन कह रहा है ए सिंपली सपोर्टेड बीम ऑफ लेंथ 3L is subjected to the loading given below. It is given that P is equals to 1 Newton, L is 1 meter, Young's modulus is this, the cross section is square, the bending stress at point A located at the top surface of the beam. Very good Gautam. The top surface of the beam at a distance of 1.5 L from the left end edge. Okay, तो कोई पॉइंट है बेटा, टोटल लेंथ 3L है, तो हाफ पे कोई पॉइंट दिया गया है A on the top surface. So question is asking to you what is the bending stress. So what is given to you first? You can see here load is given to you here 1 Newton, right? Length is given to you here 1 meter. L is given to you 1, not length. L is 1 meter. Total length is 3L actually, and E is equals to 200 gigapascal. E is equals to 200 gigapascal. The cross section is square. It means side is given to you 10 mm. Now question is asking to you what we have to do. We have to find here bending stress at A. So now you can see question is completely silent about R term here. Definitely I have to use M upon I is equals to sigma upon Y. So sigma is equals to M upon I into Y. I is given to me, Y is given to me, only M is there. So can I find bending moment at section this? Can you find bending moment at this section? For bending moment, what do you need? For bending moment, we need support reaction. Can you tell me how much support reaction is coming on left and right support? What is the support reaction at left and right support? Anyone tell me fast, beta? What is the support reaction at left and right? Anyone fast? What is the support reaction? What is the support reaction? एक बात बताना, किस किसने सपोर्ट रिएक्शन निकाली है यहां पे कैलकुलेशन करके? कितने लोग निकाल रहे हो कि हाँ भाई सिग्मा एम ए इज इक्वल टू 0? मैं लिख सकता हूं डायरेक्टली सपोर्ट रिएक्शन यहां पे? क्या मैं लिख सकता हूं डायरेक्टली सपोर्ट रिएक्शन यहां पे बेटा? क्या मैं लिख सकता हूं? यस और नो? हाँ भाई मैं लिख सकता हूं. कैसे लिख सकता हूं? देखो यार, these two forces are equal, opposite and parallel. These two forces are equal, opposite and parallel, right? It means they are forming a couple. They are forming a couple. They are forming a which couple here? You can see they are forming a clockwise couple. They are forming a clockwise couple. So definitely my reactions will form which couple? My reactions will form which couple? Anti-clockwise couple. Yes or no? One is, if my forces are forming a clockwise couple, my reactions will form here anti-clockwise couple. Anti-clockwise couple means my reactions will form the couple. Anti-clockwise means this reaction must be downward, this reaction must be upward. Yes or no? These reactions must be upward, these reactions must be downward. Now can you tell me what will the reaction magnitude here? What will the reaction magnitude here? Anyone can tell? Anyone can tell? Anyone can tell what is the reaction magnitude here? Anyone? भाई दो रिएक्शन है, दोनों क्या कर रही हैं? एंटी क्लॉकवाइज कपल फॉर्म कर रही है. उसके लिए कपल कैसे निकालूंगा मैं? वहां पे कपल की वैल्यू क्या है बेटा? P इंटू एल. तो यहां पे लेंथ टोटल क्या है? 3L. लेंथ क्या टोटल यहां पे? 3L. तो मेरी रिएक्शन क्या होगी यहां पे? P/3. P/3. रिएक्शंस विल बी P/3 बिकॉज लेंथ इज L plus L plus L. So P into L upon 3L. Okay, P into L upon 3L. It will be P/3. So now I want moment at A. Moment at A, because we want sigma at A. So moment at A. Just calculate the moment at A. So it will be P/3 into the distance between A point and this. How much it is? L plus L/2. L plus L/2. It means it will be 3L/2. How the movement will be due to this? It will be sagging, hogging. It will be sagging, hogging. It will be hogging. So minus. Next, due to this P. So due to this P into L/2. It will be sagging. So plus. How much it's coming? You can see 3 to 3 cancel. MA is coming 0. MA is coming 0. If MA is 0, you can say here sigma A will be also 0. If MA is 0, sigma A will also 0. It means Answer is 0. Okay, answer is 0 beta. Okay, anyone doubt? Anyone doubt? Anyone doubt? ये दिमाग मत लगा देना बेटा, एक पी यहां पे एक पी यहां पे है तो भाई करेक्ट। ये दिमाग मत लगा देना भाई कि एक पी ऊपर है एक पी नीचे है तो यहां भी पी रिएक्शन आ जाएगी और यहां भी पी रिएक्शन आ जाएगी, ठीक है, ये दिमाग मत लगा देना। वेरी प्रोबेबिलिटी है एग्जाम में ये दिमाग लगा दोगे कि एक पी यहां पे है एक पी यहां पे है तो रिएक्शन या तो जीरो कर दोगे तुम, या तो तुम कह दोगे रिएक्शन जीरो है क्योंकि दोनों फोर्सों ने बैलेंस कर दिया एक दूसरे को, तो तुम कह दोगे रिएक्शन जीरो है। तो ऐसी मिस्टेक मत करना भाई, अगर हल्का सा भी डाउट हो एक लाइन लिख के कैलकुलेशन कर लेना रिएक्शन क्या निकल रही है बेटा, ठीक है। बिकॉज अगर ऐसे जहां जीरो वाले क्वेश्चन ना सबसे डेंजरस होते हैं, द क्वेश्चन दो जब आंसर जीरो ना, दो क्वेश्चन आर मोस्ट डेंजरस क्वेश्चन। ओके, whenever the options are also present like a zero, so read the question 2 times. If you're marking the answer zero na, read the question 2 times there. Okay, हमें पता है बेटा। नेक्स्ट क्वेश्चन, कुछ नया सा कॉन्सेप्ट है बट क्वेश्चन यहां पे सॉल्व कर सकते हैं हम लोग, ठीक है। इस क्वेश्चन में एक नया सा फॉर्मूला यूज होगा। आई होप सो यू नो द प्रिंसिपल स्ट्रेस कॉन्सेप्ट। ओके बेटा, दैट्स व्हाई आई एम पुटिंग दिस क्वेश्चन हियर। ट्राई दिस क्वेश्चन फर्स्ट। An 80 meter long simply supported elastic beam of rectangular cross section 100 into 200, क्या क्या दिया हुआ है? The length is 8 meter. The length is 8 meter given to us and cross section is how much given to us? 100 into 200. The cross section is 100 into 200. It's subjected to uniformly distributed load of 10 kilonewton per meter over the entire span. Okay, over the simply supported beam is there. It is subjected to UDL of 10 kilonewton per meter of at entire span beta. Okay, the maximum principal stress in megapascal up to 2 decimal place at a point located at the extreme compression edge of the cross section. If I draw the cross section in a simply supported beam, if loading is like that, where the compression will come? On the top fiber, bottom fiber. In simply supported beam subjected to UDL, where the compression will come? Top fiber, bottom fiber. Where the compression comes? Top fiber, bottom fibers. Where the compression comes? Top, bottom. The compression comes at top fiber. So here we have to find the, what? What we have to find here? Maximum principal stress. We have to find here maximum principal stress at the top fiber because here the compression comes beta. So what is maximum principal stress formula? I hope so you know. The formula is sigma x plus sigma y by 2 plus under root of sigma x minus sigma y by 2 square plus tau xy square. We will discuss this thing in a detail, okay, analysis of stress and strain, but the question demand was here, so I am taking this question here only. So sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 whole square plus tau xy square. Bhai, what is the question now? A simply supported beam subjected to bending moment. It means, sorry, subjected to UDL. Due to this, which stress will develop only? Due to this, which stress will develop? Due to this, which stress will develop? If you see here, due to this only the bending stress will develop, which will be which direction? Which will be normal to the plane. It means that will be our sigma x. So sigma x will be m upon I into y beta. Okay, m how you will calculate? It's asking to you maximum, so definitely you have to use here m maximum and y maximum. Yes or no? So you will get sigma x value here. Okay. Sigma y will be how much here? Sigma y will be how much here? Sigma y will be how much here? Sigma y will be here. Sigma y will be 0 because only the bending is there. So due to bending, stress will develop in a x direction, that will be sigma x. X means normal to the plane beta. x means normal to the plane, right? So sigma x will be m upon I into y, sigma y will be 0 and tau xy. Third is tau xy. I will discuss in a detail, but now I am telling to you, in a rectangular cross section, shear stress distribution is like that. Okay, so you can see at the top fiber where the y is maximum, our shear stress is 0. So you can see here tau xy is also 0. Tau xy is also 0, yes or no? Yes or no? Yes or no? Tau xy is also 0, yes or no? Tau xy is also 0. Tau xy is also 0. So you just, what you do, you just put all the value here. You just put all the value here. सर 20 भी तो ऊपर भाई शियर फोर्स तो है, मैं नहीं कह रहा शियर फोर्स नहीं है, शियर फोर्स आएगा, बट शियर फोर्स का जो डिस्ट्रीब्यूशन होता है ना, जो शियर स्ट्रेस का डिस्ट्रीब्यूशन होता है वो यहाँ पे टॉप फाइबर पे शियर स्ट्रेस जो है वो 0 होगा, ठीक है। जब अभी हम डिस्कस करेंगे शियर स्ट्रेस तो वहां पे देखोगे कि ड्यू टू डायरेक्ट शियर फोर्स इफ यू पुट द वैल्यू देयर द शियर स्ट्रेस विल बी 0 एट द extreme fibers. Okay, shear stress will be 0 at the extreme fibers. That's why I'm not saying shear force is not there. Shear force is there definitely यार, definitely shear force आएगा वहां पे, मैं नहीं कह रहा shear force नहीं आएगा, shear force definitely will come, but shear force thing is you know where the m is maximum, where the shear force is also 0. I'm not saying you can say that shear force is coming at ends, but shear force distribution at the edge are at the extreme fibers are 0 beta. Okay, shear force distribution is 0 at the extreme end. So if you will take that, that will be 0. So tau xy will be also 0. So you can put the value of here sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 whole square plus tau xy square. So sigma y is 0, sigma x plus sigma y by 2, it will come outside, it will become only sigma x. So you can just calculate the value here, you will get the answer of this question. Okay, so just do the calculation. Moment you can calculate here, it will become WL square by 8. Moment will come, sorry. Okay. The point located the extreme fiber cross section at 2 meter. I missed one thing. They are asking to you here at the 2 meter distance. They are asking to you here. I thought it's a maximum, but at the 2 meter. Okay, but they are asking to you here at a 2 meter. So what will we do? We can calculate here the bending moment. But thing is again, the shear stress distribution at the extreme fiber is 0 beta. Okay, shear stress distribution at the extreme fiber is 0. So you can calculate there. Okay, you can calculate sigma shear stress distribution is 0. So it will be definitely tau xy term will be vanished because at extreme fiber shear stress distribution is 0. Okay, so you can calculate there because I have to complete the shear stress. So little first you can do the calculation of this question. Okay. Next question is this. Again, it's very good question. All of you try this problem. Whatever my answer is coming. All of you try this problem. This is the recent question of GATE 2021. All of you try. All of you try this problem. What question is saying? An overhanging beam PQR is subjected to UDL 20 kilonewton per meter as shown in the figure. Okay, as shown in the figure, this diagram is given to you. The maximum bending stress developed in the beam is megapascal. What we have to do? LPI, we can take that doubt later. Okay, we can take that doubt later. Mayank, very good. Okay, so those things if you check in the calculation, I also have to check the calculator there. Okay, ln x by 4 equals to 0.419 गेट कैलकुलेटर में कैसे सॉल्व करो? क्या दिक्कत है इसमें यार सॉल्व करने में? ln x by 4 equals to 0.419 e to the power 0.419 तो निकाल लोगे ना, उसमें क्या प्रॉब्लम है? ln x by 4 equals to 0.419 है तो निकाल लोगे ना उसे, e to the power 0.419 multiply by 4, right? So what question is asking you here? Find the maximum bending stress. Again, you know, if you need maximum bending stress, what is maximum bending stress? Sigma max is equals to m upon I into y max. Sigma max for y max, definitely m will also max. Okay, okay. So right, m will be m max upon I into y max. Right, what we have to do? M max upon I into y max means we need maximum bending moment. I we will calculate because cross section is given to me here. I we can calculate because cross section is given to me here, right? We can calculate here. But thing is, how to find maximum bending moment? You know, yesterday we have discussed the bending moment will be maximum where the shear stress will change its sign beta. When the bending moment will be maximum, when the shear stress will change its sign, then the bending moment will be maximum, right? So what will you do first here? We will draw the shear force diagram of this. We will draw the shear force diagram of this. How we will draw shear force diagram? How we will draw shear force diagram of this? How we will draw shear force diagram of this? For shear force diagram, we need, for shear force diagram, what do you need? For shear force diagram, we need here support reaction, yes or no? For shear force diagram, we need support reaction. So first find the support reaction here. Can you tell me how much support reactions are coming? Can you tell me how much support reactions are coming? Do it fast. Everyone, tell me how much support reactions are coming. Do it fast. Tell me how much support reactions are coming. Everyone. Support reaction, how much it's coming? If you do the calculation, reaction at P is coming and reaction at Q is coming. I am giving you 10 more seconds. 10 more seconds. Tell me how much it's coming. Tell me how much it's coming. How much? The reaction at P is coming here beta 15 kilonewton and reaction at Q is coming 45 kilonewton. Okay, the reaction at P is coming 15 kilonewton and reaction at Q will come 45 kilonewton. So now what you can draw the shear force diagram. I told you yesterday the reaction at support will be, shear force at support will be equal to the reaction at the support. So here how much reaction? 15. So shear force diagram will come somehow like that. Here it will go 15 definitely. Now here you can see the UDL is downward. How the shear force will come? The shear force diagram will come like that, yes or no? Shear force diagrams will come like that, yes or no? So how much shear force will be there here? How much shear force will be here? Anyone can tell? 20 into 1. How much shear force will be here? 20 into 1, yes or no? How much shear force will be here? Shear force will be here 20 and total reaction is here 45. So 25 will go here. So 20 kilonewton, 25 kilonewton. So again you can see here, like yesterday's class, shear force is changing the sign at two places. One is this, other one is this. So what we have to do beta? We have to calculate bending moment at both the points, here also and here also. Okay, we have to calculate bending moment at both the point, here also and here also. Then we have to see which bending moment is maximum. Okay, then we have to see which bending moment is maximum. Based on that, we will calculate the bending stress. So what will you do? First find this distance. Can anyone tell me how much this distance is coming? Apply similar triangle property. How much this distance is coming? How much this distance is coming? if you solve, this distance is going to come 0.75 meter. This distance is going to come 0.75 meter, and if you calculate the bending moment at both the point, this is my Q point, this is my R point, I am saying this is my S point. So you will calculate bending moment at Q and bending moment at S. If you calculate at Q, how much it will come? Wx square by 2. How much bending moment will come at Q? By stand at Q, see this side, so W into x by 2, how much it will come? W is 20 into 1 by 2, definitely it will come 10 kilonewton meter. At Q it will come 10 kilonewton meter. At S how much it will come? You can calculate. S how much it will come? 15 into 0.75, 15 into 0.75 minus 20 into 0.75 square by 2, and here it will be sagging, so I am taking plus, here it will be minus 20 into 0.75 square by 2. Can you calculate how much it's coming? Can you tell me how much it's coming? Moment at S, how much it's coming? If you solve, it is going to come 5.625 kilonewton meter. So which bending moment is maximum? 10 is maximum. Use 10 here. So sigma max is equals to 10. It's a kilonewton meter. Question is asking to you in megapascal. So convert into Newton meter. 10 into 10 to the power 6. I will be how much? 24 into 100 cube by 12, because BD cube by 12 into Y max. Y max will be how much here? 100 by 2. It will be 50. If you solve this thing completely, the answer will come here 250 megapascal. Okay. If you solve this thing completely, answer will come here 250 megapascal. Okay. Answer will come here 250 megapascal. That will be the answer of this question. Okay. Only the thing is the question is little lengthy. अच्छा अच्छा ठीक है. मैं एक्चुअली ना अभी तक जो क्वेश्चन एग्जाम में आए हैं उसमें ना अभी तक कभी बेंडिंग मोमेंट यहाँ पे बीच वाले पोर्शन में मैक्सिमम आया नहीं है. ठीक है. मैक्सिमम बेंडिंग मोमेंट जनरली एक्चुअली एक कॉन्सेप्ट कहता है बेंडिंग मोमेंट विल बी मैक्सिमम where the overhang is maximum. Okay, if overhanging beam is there, so maximum bending moment will be at the where the overhang is maximum. Okay, so like if you are from civil, so if you maybe you know the concept of influence line diagram, there we use this concept to find the maximum bending moment. We consider where the overhang is maximum, there the bending moment will be maximum. Okay, so 99% chance is there the bending moment will be maximum here only. Okay, bending moment will be maximum at the maximum overhang side only. So you can calculate directly there. Okay, you can calculate directly because it's a overhanging beam. Common sense है यार, अगर कोई पार्ट लटका हुआ है ना, कोई पार्ट लटका हुआ है तो बेंडिंग मोमेंट तो वही मैक्सिमम, वही ज्यादा बेंड करेगा ना यार. कौन सा पार्ट ज्यादा बेंड करेगा? ये वाला पार्ट ज्यादा बेंड करेगा, तो बेंडिंग मोमेंट भी वहीं पे मैक्सिमम होगा. ओके, but here the loading is uniform, that's why you can say if the loading is non-uniform, let us say here they put us some other intensity, here they put us some other intensity, then it will be changed. Okay, then it maybe will be changed. So that's why we are not making any statement here. Okay, that's why we are not making any statement here that definitely it will be maximum at there. No, depend upon the loading condition also, but if the loading is uniform, same loading is there, so definitely it will come maximum at the support only. Okay, all right, next question. This is a GATE 2006 question. Okay, this is a GATE 2006 question which I was talking to you. All of you try and tell the answer first. All of you try and tell the answer first. All of you try. What question is saying, beta? A beam with the cross section given below is subjected to a positive bending moment cause compression at the top. It means simply supported beam is there of 16 kilonewton meter. Okay, no problem. Acting around the horizontal axis. It means horizontal axis means definitely it should be horizontal neutral axis. So bending moment is acting here somewhere here. Okay, the tensile stress acting on the hedged area of the cross section is what we have to find. Force on the hedged area. Force on the hedged area. Okay, so just now I told you how to find force on the hedged area. force on the hedge area is equals to m upon I into a y bar. M upon I into a y bar. What is m beta? M is given to you 16 kilonewton meter. 16 kilonewton meter means 16 into 10 to the power 6 Newton mm. I. What is I here? I is the neutral moment of inertia about neutral axis of whole section. Okay, it's a complete about neutral axis moment of inertia. So what is the section dimension? 100 into 75, 25, 50. Sorry. Excuse me. Sixteen into 10 to the power 6 is our bending moment. I will be how much beta? 100 into 150 cube by 12. Yes or no? Because 75 plus 25 plus 50. How much it will be? It will be 150. So BD cube by 12 into A into Y bar. A is how much? A is the hedged area. A is the hedged area. So this area is hedged. This area is hedged. How much it will be? This area is hedged. How much it will be? You can see 50 is this and this one is 25. So 50 into 25 into Y bar. Y bar is how much? Y bar is the centroid of hedged area from the neutral axis. So what this is our neutral axis. This is our neutral axis where the centroid will be of this hedged area. Centroid will be half of this, yes or no? Centroid will be half of this. It means centroid will be at 25 by 2. Centroid will be at 25 by 2. All of you do the calculation. Tell me how much it's coming. All of you do the calculation. Tell me how much it's coming. Do it fast. So it's very simple. It's a one line question looking big, but it's a one line question beta. Tell me how much it's coming. Answer. All of you do it fast. Thank you, Nitin. Very good, Ankit. All of you do it fast. What answer is coming here? Everyone do it fast. Answer, Mayank, Bhagesiri, Jyoti. Answer. If you solve it completely here, the answer is going to come 8.9 kilonewton. Okay, answer is going to come F is equals to 8.9 kilonewton beta. Okay, answer is going to come 8.9 kilonewton. Okay, so just remember M upon I into AY bar. It can be written as sigma max upon Y max also. Okay, if question have given you maximum bending stress, then you can use the sigma max upon Y max is equals to A into Y bar beta. Okay, so go to the next question now. Move to the next question. Next question is this. The very good question. Okay, this is very good question. (9.4). Just check, Mank. It's the 8.9. Just check once. Just check once. Everyone check the calculation once again. Ankit, you also check the calculation once. It's 8.9 only, right? It's 8.9 only. It's 8.9 kilonewton. Now see what question is saying here. The maximum tensile stress at the section XX shown in the figure below is. आंखें खोल लो ध्यान से बेटा, आंखें खोल लो ध्यान से. The question is really good here. The question is really good. Okay. So we have to find maximum bending stress at this section XX. ठीक है. सेक्शन एक्स एक्स, अब सेक्शन एक्स एक्स को थोड़ा जूम इन कर लो, सेक्शन एक्स एक्स को थोड़ा जूम इन कर लो, मीनिंग माई सेक्शन एक्स एक्स इज हियर बेटा, इट्स हियर, सेक्शन एक्स एक्स इज हियर.